Section 2.6, Ratios and Proportions. We're only going to look at a small part of this section. We'll start here at the beginning in a brown box. Page 152 at the beginning of the section, the brown box will define a ratio for us. It says the ratio of a number A to a number B, where B is not 0, is written as follows: A to B, A colon B, A over B. We actually read all of these aloud the same way. A to B, A to B, A to B. Just above the brown box, it tells me that a ratio is a comparison of two quantities using a quotient, in other words, a division, which makes it a multiplicative comparison. If I told you I had two apple trees and they produce at a ratio of 2 to 1, what is that telling you? That's telling you that the one apple tree produces 2 apples for every 1 apple the little guy gives. If the big apple tree produced 50 apples, I would expect the little apple tree to produce 25. It is a multiplicative relationship. And typically in algebra, we like to see it as a fraction. This is one exception to leaving an answer over 1. If you are talking about a ratio, and I say, what is this ratio? If the ratio is 2 to 1, and we know we're talking about a ratio, I want to see both of those numbers, the 2 and the 1. This is one time you can leave an answer over 1, because you're expected to be comparing two numbers. We're going to be reducing these ratios. Consider if I had a jar full of marbles. Okay? Let's say that I've got 4 red marbles and 6 blue marbles in this jar. Then the ratio of red to blue marbles, 4 red to 6 blue, which I could reduce to the ratio 2 to 3. In other words, for every 2 red marbles in this jar, there are 3 blue ones. For every 2 red ones, there are 3 blue ones. If I told you that I had a jar full of marbles and the ratio red to blue was 2 to 3, and that there were 40 red marbles, if I told you there were 40 red marbles, well then a ratio of 2 to 3 will tell you there must have been 60 blue marbles, because for every 2 reds I have 3 blues. In other words, I can change this 2/3 to, what did I say? If we have 40 red, well, how do you turn a 2 into a 40? Multiply by 20. If I do that also to the bottom, that gives me my 60 blue. Let's look at the homework set and see some of the ratios they're going to have us reduce. Number 4, here on page 158. Start with number 4. It says, write a ratio for each word phrase, express fractions in lowest terms. What I will probably do on a quiz or a test is something like, reduce the ratio. And number 4, reduce the ratio 60 feet to 70 feet. In algebra, we're going to want to write these as fractions. So we will write this as 60 feet to 70 feet. And the nice thing about units in a fraction is they'll cross cancel, just like any other factor. Feet cancel, and 60 over 70 reduces to 6/7. So my final ratio is the ratio 6 to 7, which means, this is a multiplicative comparison, it means that 60 feet is 6/7 as big as 70 feet. Notice that this ratio has no units. A ratio should come out dimensionless, that is, without units. Rates, on the other hand, like miles per hour, okay, if you're going 120 miles in 2 hours, 120 divided by 2 is 60 miles per hour. This still has units on it. That's a rate, as opposed to a simple ratio. We're dealing with the ratios, so our answers should come out dimensionless or without units. With that in mind, look at number 8. In number 8, we are to reduce the ratio 30 inches to 8 feet. So let's write it as a fraction. 30 inches to 8 feet. I've got different units, but they are both units of length, so I can turn one of them into the other. Now, what would you prefer? That this be in terms of inches or in terms of feet? I would rather not change 30 inches into feet. That's going to make this more complicated than it needs to be. Let's change 8 feet into inches. And so 30 inches to 8 feet is how many inches? 8 feet times 12 inches a foot is going to be 96 inches. Now that the units match, they will cancel, and we will end up with no units. We'll end up with a dimensionless quantity. Now let's see what we can divide both of these by to reduce this. They're both divisible by 2. They're both divisible by 3, so they must be divisible by 6. 6 goes into 30 5 times. 6 goes into 96 16 times. And that is reduced to lowest terms. What this tells me, it's a multiplicative comparison. It says that 30 inches is 5/16 the size of 8 feet. Now, I want to look at this another way. You may remember using unit conversion factors in a physical science class. And this is the way I prefer to do things. There's nothing wrong with what we just did, but I can multiply this ratio by a unit conversion factor. Factor means we're multiplying. Unit means it will be equal to 1. Conversion means we're changing the units. I can put inches on the bottom and feet on the top, knowing that 1 foot is 12 inches. Look, that's something over itself. 1 foot, 12 inches, same thing. And something over itself is 1. This is just a big blue 1. When you multiply something by 1, you might change the way it looks, but you're not going to change its value. And now watch what happens. The inches will cross cancel, feet will cross cancel, and I'm left dimensionless. Also, instead of dealing with a 96 this time, what can I do? I can go ahead and start cross-canceling right now. 6 goes into 12 twice. 6 goes into 30 5 times. I've cross-canceled everything I can. Multiply the tops. Multiply the bottoms. 8 times 2 is 16. Same answer. But I think this way is a little slicker. For one thing, it keeps your numbers smaller and easier to work with. Use whichever method you see fit. Just remember, it has to come out without units. A ratio needs to be dimensionless at the end. Let's try number 10. Number 10, the ratio 16 minutes to 1 hour. So we'll write it as a fraction. We know that these units are going to have to cancel. Would it be easier to change 16 minutes into hours or 1 hour into minutes? It's going to be easier to change our hours to minutes. So let's rewrite this as 16 minutes to 1 hour is 60 minutes. And now my units will cancel. Then we reduce 16 over 60. They're both divisible by 4. That's going to give me 4 and 15. 4/15. In other words, 16 minutes is 4/15 of an hour. If we use a unit conversion factor, it would look like this. Although in this particular problem, we're not going to see any great advantage with the numbers. Hours on top, minutes on the bottom, so they will cancel. I know that 1 hour is 60 minutes, so this is something over itself, which is a big blue 1, a unit conversion factor. Minutes cancel, hours cancel. 4 goes into 16 4 times, 4 goes into 60 15 times, and of course we get the same ratio. So either way, you will find that using unit conversion factors will serve you well later in your lab sciences. If you have a chemistry or a biology or a physical science class coming up, those unit conversion factors make for a very powerful tool. Let's turn our attention now to proportions. We've talked about ratios. Let's define a proportion. We'll turn back to page 153. On page 153, right under objective 2, here toward the bottom of the problem, it reminds us that a ratio is used to compare two numbers, and it says a proportion says that two ratios are equal. A proportion is a statement that two ratios are equal. For example, 1 is to 2 as 5 is to 10. This is a mathematical analogy. You've done analogies before. You remember the standardized test where you had little circle is to big circle as little square is to what? Big square. That's an analogy. Well, this is a numeric analogy. It's saying 1 is related to 2 in the same way that 5 is related to 10. 1 is half of 2. 5 is half of 10. It has the same multiplicative relationship. Now, in general, a proportion says that some number A is to some number B as C is to D. Now, what I'm going to do is something that we see more of when we get into college algebra. I'm going to derive one of our rules for us. Let's look at this as an equation. It is. An equation with fractions. Wonder what would happen if I cleared the fractions. Multiply both sides by BD. On the left-hand side, the B's will cancel to leave A times D. On the right-hand side, the D's will cancel to leave B times C. What does this mean? This means that in any proportion, it will always be true that this product, A times D, will always be equal to that product, B times C. And this is cross-multiplying. Has nothing to do with cross-canceling. Don't get the two confused. This is cross-multiplying. Look at our statement that we had a minute ago. 1 is to 2 as 5 is to 10. If that's true, then it should be the case that the cross products are equal. That is, 1 times 10 is 10, and 2 times 5 is 10. And so that tells me that that ratio, that proportion is correct because the cross products match. By the way, the A and the D, over here, the 1 and the 10, those are called the extremes. The 2 and the 5, the B and the C, those are called the means. Extremes means on the outside, means in the middle. And if I were to write this like 1 is to 2 as 5 is to 10, you can see why I call the 1 and the 10 the extremes. Those are the outsides. The 2 and the 5, the ones in the middle. So we say the product of the extremes equals the product of the means. We have this in a brown box, page 154. Our brown box on page 154 says that if A over B equals C over D, then the cross products are equal. That is, the product of the extremes equals the product of the means. It goes on to say that works the other way. If the cross products are equal, then the proportion must be true, is what that boils down to. Here in problems 23 through 28, you'll be doing the 3 odd ones. All you're doing is this right here. You're checking the cross products to see if they match. If they match, then the proportion's true. If they don't match, then the proportion's false. And it's as simple as that. We can also use cross-multiplying to solve proportions. Look at number 30. The instructions will simply read, solve. X is to 6 as 18 is to 4. Solve for X. Well, this is a proportion, meaning I can cross-multiply and set the cross products equal to each other. Now, very careful. If there were anything else going on in this problem, it's no longer a proportion. You can't use cross-multiplying unless it is simply a fraction equals a fraction. Then you can cross-multiply. We know that the product of the extremes, x times 4 is 4x, equals the product of the means. 6 times 18, what will that give me? 108. And divide both sides by 4. Divide both sides by 4 to find that x is 27. As straightforward as that. Now, frankly, here's what I would do. Nothing wrong with this. Nothing wrong with this. However, I can make life a little easier on myself if I pay attention. The first thing I might do is reduce this fraction on the right. 18 over 4 reduces to 9 halves. I like those numbers better. When I cross multiply now, product of the extremes, x times 2 is 2x. Product of the means, 6 times 9, 54. Divide both sides by 2. Yeah, I like that a little better. I don't always have that option, but if I see something that will make things a little easier on me, that's what I'm going to want to do. Let's look at number 36. Solve. M is to 5 as m minus 2 is to 2. Cross multiply. This is a proportion. Fraction equals a fraction. So we can start by cross multiplying. It's just another way of clearing the fractions, really, isn't it? Product of the extremes, m times 2, 2m. Product of the means, 5 times that. Let's just write it, 5 times that. Little pieces, little bite-sized pieces. Don't get ahead of yourself, because that's when you make a silly mistake. Now that we see what's going on, we need to distribute that 5. We're just solving this equation now. Distribute the 5. I'm going to collect my m's on the left. Subtract 5m from both sides. Subtract 5m from both sides. And divide both sides by -3. Let me go ahead and show that. Divide both sides by -3. On the left, the -3's cancel to leave m equals. And what is -10 divided by -3? Negative over negative is positive. 10 divided by 3 is 10/3. That can't be reduced any further. But do be sure and cancel those negatives. Okay, let's do one more. And let's have a look this time at number 44. This one we want to take at a reasonable pace, take our time. And let's cross multiply. We have a fraction equals a fraction, that's a proportion. Cross multiply. Product of the extremes, 9 times x minus 3 times that 2. Well, 9 times 2 is 18 times x minus 3. We'll finish that in a minute. You with me so far? Product of the means, 6 times 6 times that. 6 times 6 is 36 times that. Let's finish that off in a minute. Distribute the 18 now. 18 times 3, 54. Distribute the 36. 36 times 2, 72. I'm going to collect my x's on the right-hand side this time. Subtract 18x from both sides. Subtract 18x from both sides. Add 72 to both sides. Add 72 to both sides. Add 72 to both sides. We have 18 equals 18x. Divide both sides by 18. And x equals 1. So in a proportion, you can cross multiply to get your equation set up with no fractions. It is a method of clearing fractions that is specific to proportions. Fraction equals a fraction. We had some bigger numbers in this problem. If I look closely here at this second step, I see something we could have done. Nothing wrong with what we did, but if we're looking from time to time to make life a little easier on ourselves, why not divide both sides of this equation by 18 right now? 18 over 18 is 1, times the rest is the rest. In other words, those cancel. On this side, 36 over 18 is 2. I like that a lot better. So if I notice something like that, I can jump right on it. Nothing wrong with the other method, but it did provide us with some numbers that turned out to be larger than really we needed. Distribute the 2. Subtract x from both sides. Add 4 to both sides. Yeah, I like that better. Like I said, we're having a short look at this section. That's what we want to do. And so you are ready to tackle that homework.